This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Welcome to the discussion. Today we're diving into an interactive physics simulation designed to help students grasp the complexities of kinematics. It's a fascinating tool, and our guest is here to shed light on its capabilities.
The Velocity Time Graph Editor Simulator offers a unique approach to learning kinematics, moving beyond static textbook examples.
Exactly. It allows students to manipulate velocity time graphs directly, seeing the immediate impact on the simulated motion of an object. What's the core benefit of this hands-on approach?
The interactive nature fosters a deeper understanding of the relationship between velocity, time, acceleration, and displacement. Students aren't just passively observing, they're actively shaping the motion.
And this active learning translates to a more intuitive grasp of often abstract concepts. Let's delve into the specifics. The simulator lets users drag points on the velocity time graph. How does this direct manipulation enhance the learning experience?
It allows for exploration of various motion scenarios, from simple uniform motion to complex decelerations and even changes in direction. The immediate visual feedback reinforces the connection between the graph and the object's movement.
So it's not just about seeing the graph, it's about feeling the impact of changes on the simulated object's behavior.
Precisely. The visual representation of the ball's motion, coupled with the numerical data displayed, provides a powerful combination for learning.
The simulator offers customization options, including toggling the visibility of position time and acceleration time graphs. How does this flexibility aid in learning?
It allows teachers to tailor the simulation to specific learning objectives. By focusing on particular aspects of motion, they can guide students towards a more focused understanding. The inquiry-based approach encourages exploration and experimentation.
This aligns perfectly with modern pedagogical approaches that emphasize active learning and student-led inquiry.
Absolutely. The suggested steps in the briefing document provide a framework for teachers to guide students through targeted investigations.
Let's discuss some of the key features. The combo box allows users to select predefined motion types or edit the graph directly. What's the significance of this dual approach?
It caters to different learning styles and levels of understanding. Beginners can start with preset motions, while more advanced students can create and analyze their own complex scenarios.
And the draggable ball feature?
That allows students to directly manipulate the ball's position, providing another avenue for exploring the relationship between the graph and the physical motion. The play, pause, step, and reset buttons provide standard simulation controls for effective experimentation.
Who is the target audience for this simulator?
Primarily, physics teachers and students. Teachers can use it to demonstrate concepts, create interactive lessons, and assess student understanding. Students can use it for self-study and practice.
And what specific learning outcomes can be achieved using this tool?
Students can develop a strong understanding of velocity, acceleration, and their relationship to an object's motion. They can learn to interpret velocity time graphs and apply this knowledge to real-world scenarios. The simulation also helps differentiate between deceleration and negative acceleration, a common point of confusion.
What are the technical details of the simulator?
It's a JavaScript simulation applet HTML5, meaning it's web browser-based and accessible without plugins. Its embeddable nature makes it easily integrated into online learning platforms.
This accessibility is crucial for widespread adoption and use.
Absolutely. The provided iframe code simplifies embedding the simulator into websites or learning management systems.
The briefing document mentions integration with the Singapore Student Learning Space, SLS. How does this integration enhance the learning experience?
It provides a seamless transition between the simulation and other learning resources within the SLS platform, creating a cohesive learning environment. The links to a video explanation and additional resources further support student understanding.
This blended learning approach is very effective.
It leverages the strength of both interactive simulations and supplementary materials to provide a comprehensive learning experience.
The accompanying study guide includes quiz and essay questions. How do these assessments contribute to the learning process?
They provide a structured way for students to test their understanding of the concepts explored in the simulation. The essay questions encourage deeper reflection and application of knowledge.
The quiz answer key provides immediate feedback, which is important for reinforcing learning.
Yes, and the essay questions promote critical thinking and problem-solving skills.
How can the simulator facilitate conceptual change in understanding kinematics?
By allowing students to actively manipulate the variables and observe the immediate consequences, the simulator helps them overcome misconceptions and develop a more accurate mental model of motion. The video explanation further supports this conceptual change.
The connection between the graphical representation and the physical motion is crucial.
The simulator strengthens this connection by visually linking the graph to the object's movement, making abstract concepts more concrete and understandable.
How effective are interactive simulations like this one compared to traditional teaching methods?
Interactive simulations offer a more engaging and effective learning experience than traditional methods. They allow for active learning, immediate feedback, and personalized exploration. However, they should complement, not replace, traditional teaching methods.
It's about creating a blended learning environment.
Exactly. The combination of interactive simulations, traditional instruction, and supplementary materials provides a powerful and versatile approach to teaching kinematics.
How are displacement, velocity, and acceleration interconnected, and how does a simulator help explore these relationships?
These concepts are intrinsically linked. Acceleration is the rate of change of velocity, and velocity is the rate of change of displacement. The simulator allows students to visualize these relationships dynamically, manipulating one variable and observing the effects on the others.
And what are some real-world applications of understanding velocity time graphs?
Velocity time graphs are used extensively in various fields, including engineering, transportation, and sports analysis. Understanding these graphs is essential for analyzing motion, predicting future behavior, and optimizing performance.
The study guide includes a glossary of key terms. Why is this important?
A clear understanding of terminology is fundamental to grasping the concepts of kinematics. The glossary provides a concise and accessible resource for students to reinforce their understanding of key terms.
This ensures consistent terminology and avoids confusion.
Precise language is crucial in science, and the glossary helps establish this precision. The Velocity Time Graph Editor Simulator is a valuable tool for enhancing the teaching and learning of kinematics. Its interactive nature, coupled with its flexibility and accessibility, makes it a powerful resource for educators and students alike.
That was a great discussion. Thank you for sharing your expertise.